Lecture 3 of Unit 2 Basic Chemical Engineering. In this video, I am going to discuss about the concepts of mixer. In industries, mixer are used to mix two streams, produce a product stream of required concentration. Specifically, the spent acids from different industries will be obtained, and those acids are mixed with concentrated acids to obtain a mixture of acid of required concentration. Let's see how to draw the schematic and solve mass balance problems on mixer. So in this tutorial, two streams are going inside a mixer and they are mixed to form a one stream of product. So the first stream I want to call it as M1. The second stream entering the mixer would be M2, and the final product I'm going to call it as M3. So in the input stream, a aqueous solution of acids will be given as a feed. So it will have an acid percentage and remaining would be water percentage. Similarly, in the product stream also, we will have some amount of acid percentage. Let's solve a problem and understand this concept better. So let me read the question. Two spent acid streams are mixed in a vessel. Stream 1 has a flow rate of 300 kg per hour and it contains 25 weight percentage sulfuric acid, while stream 2 has a flow rate of 200 kg per hour and it contains 15 weight percentage sulfuric acid. Determine the total product flow rate and the acid concentration in the mixed product stream. To start with, let's draw the schematic of the mixer. Stream 1 is entering and stream 2 also is entering, and we have a stream 3 as a product. As per the question, the stream 1 has sulfuric acid. Similarly, stream 2 is also having a sulfuric acid. So stream 1 has a mass flow rate of 300 kg per hour as per the question, and it contains 25% of sulfuric acid. So the remaining 75% must be water. Moving on to stream 2. The stream 2 has a flow rate of 200 kg per hour. And it contains 15 weight percentage sulfuric acid. So the remaining 85% would be water. To find the M3 and the sulfuric acid percentage in the product stream, we'll do the overall mass balance. The overall mass balance would be, there are two streams as the input, so we have to sum M1 plus M2, and there is one output stream, so the right hand side will be M3. When you go for solid balance, as we did for dryer, crystallizer, and also liquid-liquid extraction, we multiply the mass of each stream with the respective solid percentage. So S1 percentage into M1 plus S2 percentage into M2 and S3 percentage into M3. Moving on to water balance, similarly we will multiply the mass of each stream with its respective water percentage. So let's substitute the values in the overall mass balance equation. So M1 is given, the question is 300, M2 is also given and it is 200. So the M3 would be 500 kg per hour. Let's substitute the value in the solid balance equation. So the solute in the stream 1 is 25%. When I write it in fraction, it would be 0.25 into M1, and the solute in the M2 is 15%. It would be 0.15 in fraction, so 0.15 into M2. Similarly, S3 fraction we don't know, so I'm retaining as it is into M3. So M1 value we know already, I'm substituting as 300, M2 value is 200, M3 we just found as 500 kg per hour. I'm substituting all the values, so I have only S3 as unknown. On rearranging, I can calculate S3 as 0.21. So the percentage of sulfuric acid in the product stream is 21%. So the remaining 79% must be the water percentage. Let's move on to the next problem. A product stream of 500 kg per hour containing 20 weight percentage sulfuric acid is to be prepared by mixing two spent acid streams. Stream 1 contains 35% sulfuric acid and stream 2 contains 10% sulfuric acid. Calculate the required mass flow rates of stream 1 and stream 2. In this case, the required product quantity is given. We are asked to find what would be the mass of stream 1 and stream 2 required to prepare the final product of this much concentration. So again, let me draw the schematic here. Two stream inputs are there and one output is there. So one by one we'll fill it up. Starting with stream 1. Stream 1 contains 35 weight percentage sulfuric acid. So the remaining 65 must be water. Though M1 we don't know, I am retaining M1 as it is. Coming to M2 stream, the question says stream 2 contain 10 weight percentage sulfuric acid. So sulfuric acid is 10%, so the remaining must be water. So 90% water. Moving on to product stream, the question says the product stream of 500 kg per hour. So I am replacing M3 as 500 kg per hour. And the sulfuric acid percentage is 20%. So the remaining 80% must be water. So we have filled all the values. Let's start writing the overall mass balance equation, solid balance equation, and water balance equation. Overall mass balance equation would be M1 plus M2 is equal to 100. We don't know M1 and M2, so we retain as it is. Going to solid mass balance equation, we multiply the mass of each stream with respective solid percentage. So M1 would be multiplied by S1 percentage, that is sulfuric acid percentage in the M1 stream. Similarly, S2 percentage with M2 and S3 percentage with M3. Similarly, we do for water balance equation, where we multiply the mass of each stream with its respective water percentage. Let's substitute the value and try to solve the equation. So M1 would be equal to 500 minus M2. Because we don't know M1 and M2, I'm just finding M1 in terms of M2. So 500 minus M2 would be equal to M1. Moving on to solid balance equation, I'm replacing S1 percentage by 0.35 because in the stream 1, the solute percentage is 35 percentage. So this is 0.5 percentage. In stream 2, the solute percentage is 10 percentage. So I'm replacing S2 percentage by 0.1. Similarly, for M3, I'm just replacing 0.2 as 20 percentage is the acid. Moving on to water balance. So I'm simplifying to get an equation which comes to be 0.35 M1 plus 0.1 times M2, which is equal to 100. Now in this equation, I am going to replace M1 by this particular equation, that is 500 minus M2. You can see here 0.35 into, in the place of M1, I am replacing 500 minus M2 plus the remaining term 0.1 times M2, which is equal to 100. So now this is the equation in terms of M2. We can find M2 by rearranging this equation, which comes to be 300 kg per hour. So the remaining would be M1, that is 200 kg per hour.